Okay, so we've still got 5 questions left, so we'll move on to number 6. At what interest rate, compounded annually, would you need to invest $100 in order to have $125 in 2 years? So I'll show you 2 quick solutions. We could use our method of using, that's our future value. This is the formula then, and so 125, the future value, is equal to 100, the present value, 1 plus some unknown interest rate. Let's put it over 100 so it comes out as a percentage, and then in 2 years. And so in order to solve this equation, we can set up our y1 and our y2 accordingly. So our left-hand side is 125, our right-hand side 100 times 1 plus r over 100 to the power of 2. And then let's just set up a sensible window. So we know that our y1 equals 125 represents a constant function which requires a y max of at least 125. Why don't we make it, say, 140, so it's safely above. And I don't expect the percentage to be more than 15%. This is probably a good window already, and we'll graph it. There's the constant function of 125. There's the compound interest growth function. And let's find out where they cross. Second, trace, 5, and first curve, second curve, and guess. And so a quick sketch of the situation will serve as my work. So that's y1 equals 125, and then I've got this growing function, which is y2 equals 100, 1 plus x over 100 squared, and the intersection point we can see occurs at 11.8 and 125, and that implies then that the interest rate is going to be 11.8% when I round to 3 significant figures. The other method I could have used would have been Apps Finance and the TVM solver. I'm investing $100 for 2 years, and I don't know what the interest rate is, so I'll come back and solve for that in a minute. Here's my investment of $100. It's negative because I'm investing it, and I want to eventually have a future value of 125. So I'm only compounding once a year. Sorry, all these questions are only compounding once a year. Hopefully we'll find one a little bit later on where we're compounding multiple times each year, and we'll just change the p over y and the c over y. Anyway, I'll put it to the interest rate, alpha solve, and we find out that the interest rate is just like we predicted, 11.8%. And I think we've gone over this in previous questions, but we should just copy out this entire screen into your solution to prove that you used the finance application. Question number 7, Tony invested 500 Swiss francs, that's what CHF stands for, is Swiss francs, in a bank account at a constant rate of interest. The bank calculates his balance at the end of the year, rounded to 2 decimal places as shown in the table below. So, first, what is the rate and type of interest? Now I'll notice that this one is going up, well, from 500 to 540, I can see that I had an increase of 40. From 540 to 583, I can see that I had an increase of 43.20. And so because the increase is not the same each time, it's definitely not an arithmetic sequence, it's probably going to be a geometric sequence. That's an easy thing to test for. So we'll look at the ratios. So 540 divided by the term in front of it, and that gives me 540 divided by 500, and so that's 1.08. And then if I take the next pair, 583.20 divided by the previous term, 540, so 583.2 divided by 540 gives us again 1.08, and this indicates then that we have a common ratio in the geometric sequence of 1.08. But remember, this represents the multiplier. So I'm taking my original amount of 500 and I'm multiplying it by 1.08, which I could write as 1 plus 8 over 100 to the power of x for the number of years that are occurring. And this shows us then that the interest rate is 8%. And what type of interest is it? It's compound interest, because the interest that we're earning, this $40, stays in the bank account, and then that $40 is itself earning interest thus compound interest. Complete the table for the 5th and 6th year of investment. A clever way of doing this might be to get a table so that I can see both the 5th row and the 6th row simultaneously, and then I don't need to repeat any work. So we'll go to my y equals, and I'll set up my function. So y1 is equal to 500, my original investment, multiplied by 1 plus 8 over 100. And we'll raise it to the power of x to represent the number of years that have passed. And now let's look at the table. And, okay, whoops, I've got to back up just a little bit. Alright, so I can see that in year 5, there it is, in year 5 I've got 734.66. So, 734, oops, sorry, 734.66, and in year 6, that 734.66 grew, so by the end of the 6th year, we had 793.44. Alright, number 8. Hassan invested 10,000 Swiss francs at the end of 1971. The interest rate was 5% per annum. Oh, what a shame. Again, it's annual interest. Sorry, I wish I'd selected a problem that forced you to compound monthly or something, but oh well, I hope you do understand that stuff from the previous time that we studied compound interest, and hopefully you know how to use finance. Anyway, let's do this with finance, and so we'll go, we'll say apps, finance, TVM solver, and looks like from 1971 to 1999, there are 28 years that have passed. And we're only compounding once each year, so that's a total of 28 time periods that have occurred. The interest rate is 5%. The original investment, so let's put it negative because we're giving it away at the beginning. We're losing it. We'll get back something more in the future. And the future value is what we're trying to find, so alpha, enter, and we find out that the money has grown to, now I've kind of gone ahead and calculated it without really reading the question. If he had not removed the interest from his account, I'm looking at part B first. He had not removed the interest from his account. That means that the interest stays in his account, and the interest is itself earning interest, thus the compound interest situation. So 39,201.29. And as always, we should write down the finance screen. N is 28, I percent is 5, my present value, negative 10,000. The future value becomes 39,201.29. And I should probably include the C over Y and the P over Y as well. Let's go back to part A. Let's suppose that he had removed the interest from his account at the end of each year. This means that each year there's only the original 10,000 Swiss francs left in his bank account. So let's look to see how much he'll earn after 1 year. So the 10,000 is multiplying by the 1, so that's preserving the initial 10,000 with a 5% increase. Let's see what this gives us. If we go 10,000 times 1.05, and we find that we get 10,500, and then he removes the interest. We can see that the interest earned, if we subtract the original amount, we can see that we have earned Swiss francs in interest. Now consider that there's 28 years. Each of these 28 years, he will be earning similarly a 500 Swiss franc interest amount on the initial 10,000 investment. In part B, if he's leaving the interest in the account, then of course every successive year he'll gradually get more and more interest, starting with 500, but then a little bit more the following year, a little bit more the following year. But part A says that he removes the interest each time, so not only is he going to have the initial $10,000 investment, but he's also going to have the $500 that he was earning in interest each year times the 28 years that have passed. So 10,000 plus $500 per year times the 28 years in which he's been earning it, and we end up finding part A, he's got a total of 24,000 Swiss francs. I shouldn't have put dollars here, should I? Should have been Swiss francs. Okay, number 9. John invests X US dollars in a bank. So let's just think about this. He's invested X. The interest rate is 6%. So there's the 6%. Ah, here we go, finally. Compounded monthly. So I've got to change my denominator here. I've got 100. But because it's compounded monthly, we got to multiply it by 12. And then the power is 12 times x, where x represents, oops, I should use a different variable. I've already used x as the initial deposit. So let's 12 times n, where n represents the number of years that are passed. So in part A, we need to write down in terms of x an expression for the value of John's investment, so that's the future value, after 1 year. Meaning then that instead of n being n, we've just got 1 year has passed. So there's our expression for part A. Part B, what rate of interest when compounded annually instead of monthly? So let's just write down what that means. If we're compounding annually, we don't know what the interest rate is, but if I'm only compounding annually, then it's just times 1 in the bottom, isn't it? And this is 1 times, and it's got to be the same value as what rate of interest when compounded annually? I'm going to presume that, again, only 1 year has passed. Okay, I think that's sensible. And we want to set this equal to the amount that we had in part A, because that was the value of his investment if it was compounded monthly, where the 6% was being divided between the 12 months, and then we were multiplying this 12 times instead of just 1 time to represent the 12 different months in which it's compounding. In order to solve this equation, I first need to recognize that I've got a common factor of x on both sides. If I divide both sides by x, then these disappear and these disappear, and now we've got something that we can solve for r. So here we go. Whoops. Let's go into the y equals, and we'll put in our left-hand side, 1 plus x over 100. And that amount, so I wish I'd put in a parentheses at the beginning. Okay, I'll insert a left parentheses here. Okay, there we go. So 1 plus x over 100, that's our left-hand side, raised to the power of 1, no point writing that. And my right-hand side is 1 plus 6 over, and now here's where I have to be careful. My 100 times 12 is all in the denominator, so let's divide 6 by the entire expression, 100 times 12. And we're raising this to the power of 12 to represent the 12 months in the year that have passed. Okay, so to set up my window, the interest rate is probably between 0 and 15. This part's going to be a little bit tricky though, setting up the y min and the y max. Because the x is cancelled, you could argue now that our starting value is just simply 1 in each case. So we want to make sure that we can see what's happening around 1. I'm going to set my y min at 0 and my y max at about 3 and see if that will show us what we're looking for. There's our first curve, and our second curve is, gosh, almost on top of it. It's a little bit difficult. Perhaps I should zoom in to just the area around 1. So I'm going to adjust my window. My y min, why don't we make that something like 0.9, and we'll make the y max something like 1.2. And now let's graph it and see if we get a better picture. There's the left-hand side, and here's the right-hand side. Now we can clearly see what the intersection point is going to be. So we'll say second trace to get into the calculate menu, and then option 5 for intersect. First curve, second curve, and the cursor's already nice and close to the guess, which shows us that the r value is equal to 6.16%, 6.17% if I round carefully to 3 significant figures. And as always, we should probably show a quick picture of the graph. So there's one function and there's another function, and they're intersecting at 6.17 and 1.06. And I should probably just label what the functions are. So the first one that we saw, the one that was rising, was the one y1 equals 1 plus r over 100. And the other one, the constant function, is y2 equals 1 plus 6 over 1200, all raised to the power of 12. Number 10, last question. You'll notice that we need to leave our answer to 2 decimal places. Good practice to circle that information so you don't forget. So we need to calculate the value of P. Well, we know that there's 0.64 US dollars. Let me just think about what this is saying. Sorry, 0.64 British pounds equals 1 US dollar. So 0.64 British pounds is equivalent to 1 US dollar. Now let's move up. And so that means that 1 British pound is equivalent to P US dollars. And now we're ready to cross multiply. So 0.64 times P is equal to 1. And so P is equal to 1 divided by 0.64. And we got 1.5625. And we could round, I suppose, to 3 significant figures, 1.56. Oh, in fact, I have to round to 3 significant figures. Well, not 3 significant figures, 2 decimal places. There we go. And in order to find Q, we can use a similar procedure. I can see that 1 US dollar to Q French francs is equivalent to 0.19 US dollars compared to 1 French franc. And so if I cross multiply, I get 1 is equal to 0.19 Q. And so Q is equal to 1 divided by 0.19. 1 divided by 0.19 gives me 5.26 to 2 decimal places. Part B. Joe has 1,500 US dollars to exchange at a bank. Assuming no commission is charged, how much in British pounds will Joe receive from the bank? Now, if you compare your British pounds to US dollars, we can see that British pounds we expect to get less than the number of US dollars. So let's just make sure that when we use the exchange rate, we do check our final answer and make sure that we got less. Okay, so I've got 1,500 American dollars. Do I want to multiply by 0.64 in order to get a smaller amount, or do I want to divide? If you do the two, you'll realize that we need to multiply by 0.64 British pounds per dollar, and we end up finding that 1,500 times 0.64 gives me an answer of 960 British pounds. And part II, assuming the bank charges 1.5% commission, how much in British pounds does Joe pay in commission? So our original $1,500 is being charged at 0.015. There's your 1.5%. So let's figure out how much commission in US dollars he has to pay. So at 1,500 being multiplied by 0.015. And we find that he has to pay 22.50 American dollars in commission, but they want us now to convert it into British pounds. So let's take our 22.5 British pounds, and do we want to multiply it by 0.64 or divide? Well, remember, we're converting dollars into British pounds. We're expecting to end up with a smaller amount. You'll find that you need to multiply. So 22.50 multiplied by 0.64 yields a final solution of, oh, that can't be right. Yes, I can see my mistake. It's 222.5. I should have put 22.5, which is multiplying 0.64. And there we go, 14.40. British pounds is the value that he would have paid in commission, equivalent to that $22.50 he paid in commission. How much in British pounds does Joe actually receive for his US dollars, 1,500? So his $1,500, we had to subtract the amount in commission in US dollars that he was charged, and that gives us a total of 1,500, minus $22.50 in commission, and we're left with only $1,477.50 that we need to now convert into British pounds. We've learned by now that to convert from dollars into British pounds, we need to multiply by 0.64, and we get an answer then of 945.60 British pounds is the amount that he'll actually receive. And this makes sense, doesn't it? Because you look at the 960 British pounds that he received if there was no commission. But then he was charged 14.40 in British pound commission. So another way you could have solved this problem is simply by taking the 960 pounds that he should have received, subtract the amount in commission from British pounds, and again, you'll end up with 945.60 British pounds. And the last part of this question is part C. Oops, there's a part D. I'll do that in a minute. Part C. Joe decides to invest $700 of his money in a savings account which pays interest at 5% compounded annually. So 700 British pounds is increasing by 5% compounded annually, so I don't need to worry about any K values, and it's to the power of 4. So what is 700 times 1.05, a 5% increase, raised to the power of 4 to represent 4 years have passed, and I find out that in money, remember, I've got to round to two significant figures, two decimal places, 850.85. Now the question is a little bit tricky because it says how much interest will the $700 pounds earn. So the 700 pounds started with seems like an extraordinarily high amount. Let me just think for a moment. 5 times... Yeah, it does make sense. Okay, so 850.85 is what he actually ends up with. Let's subtract the initial amount, and we discover that the amount that... the difference, that is the amount that he's earned in interest during those 4 years. So 150.85 British pounds is the amount that he has earned in interest. For how many years must Joe invest his 700 British pounds in order to earn at least 200 British pounds in interest? Okay, so the 700 original British pounds we know is growing at a rate of 5% per year. I don't know how many years it is, but this will represent the actual amount of money is his bank account. If we want to find out when he has $200 in interest, let's subtract the initial $700. So this is the total amount that he has minus the initial amount, and that will represent the amount of interest that he's earned, and we know that we need him to have at least $200 in interest. So because we're compounding each year annually, then we expect our answer to be a whole number of years, because he's not getting a full amount, he's not getting his compound interest until the end of each year. So I could use a table in this situation. I'll say y equals, let me just clear these old functions. So our left-hand side is 700 times 1.05 to the power of x. And my right-hand side, that didn't look good up there, did it? What can I do to save that? Yeah, this never works, so I'm just going to start again. 700 times 1.05 to the power of x. There we go. And the right, I forgot, I've also got to say minus 700 as part of the left-hand side. There it is, minus 700. My right-hand side is simply 200. Alright, let's check the graph. Before I do that, I'll adjust my window. I know that I'm going to have a constant function coming across at 200, so let's make sure that gets included by saying 250 or something. I'm looking for a number of years. It's probably likely that it happens between 0 and 15 years. I guess I could graph it to see whether I can see the intersection. Oh, there it comes. So I could use a graph to do this, but then round up my answer. I'll show you what I mean. Second calc intersect, enter, 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 and I get an answer here of 5.15 years. But remember that he's not going to earn his interest until the end of each year. So at the end of the 5th year, he doesn't yet have enough. It's not until the end of the 6th year that he receives that 6th year of compound interest, finally pushing him over the £200 in interest. But I said I'd do this with a table. So we'll say second table, and you'll see that if we compare the 5th row, where we don't quite have enough, to the 6th row, where we finally do have enough, then clearly it will take him 6 years in order to surpass 200 in interest. And so we should copy out the 5th row of the table, so 5th row and the 6th row, and when we were at the 5th row, we only had 193.4, which was less than 200. It was in the 6th year that we finally surpassed 200 by getting 238.07. And don't forget to write your conclusion that therefore it takes 6 years. And lastly, part D. After 4 years, Joe has a total of 900 British pounds in his savings account on an investment at 5% interest compounded annually. How much did he originally invest? This is a great opportunity to use Apps and Finance TVM Solver. And so we know that 4 years have passed and we're compounding annually once each year, so only 4 compounding periods have passed by. The interest rate is, as it frequently is for IB, 5%. The present value of the money is what we are trying to find, so let's put it in as 0. And the future value of the money is 900. So let's find out what the initial investment was, the present value of the money. We expect it to be a negative value to show that we were giving away the money, investing the money. Alpha, enter to solve. And we can see that the initial investment was negative, or, well, we can just write down the original bank account balance of 740.43. 740.43 British pounds was the amount that he originally had in his savings account, and then it grew after 4 years to become 900. Once again, you should show your work by including the entire finance table of values that appears on your calculator. I don't have room to fill them in at the bottom of my sheet, but I've done it in previous questions above. I'm sure that you know exactly what I mean. And I hope that this is going to prepare you for your quiz covering the 4 concepts of currency exchange, commission, compound interest, and depreciation. And I hope you remember that you can use an equation and then use a graph or a table to solve it, or if it's a compound interest or depreciation question, then you could use the finance application, as long as you do copy down the screenshot of all of the values in finance. Okay, good luck studying. Bye-bye.